you why this rule works when we're dividing power. So we're going to write 10 to the power of 5 in expanded form as repeated multiplication. So what does that equal to? How many times do I have to write the number 10? Trizanne? 5 times. 1, 2, 3, 4, 5. Another way to show division is as a fraction, right? Divided by 10 to the power of 3. Okay, so it's divided by 10 times 10 times 10. Well, when you divide a number by itself, what's 10 divided by 10? 1. It cancels itself out because anything times 1 is still the same answer. 10 divided by 10 again, cancels out. 10 divided by 10 again, cancels out. How many am I left with?
10.
2. So we have 10 to the power of 2. Okay, because 10 divided by 10 is 1. Well, if I multiply my answer by 1, does it change? 10 to the power of 2 times 1 is still 10 to the power of 2. So even though this is 1, okay, anything times 1 is whatever that value was. It doesn't change anything. Okay, so let's try 10 to the power of 8 divided by 10 to the power of 5. I want you to write this in expanded form. So how many times do I have to write the base? 8, good. 1, 2, divided by 10 to the power of 5. So how many times do I write that? 5. 1, 2, 3, 4, 5. And then we know that we can cancel these out. And how many am I left with? How many 10s am I left with? 3. So as a single power, simplified, this is going to be equal to 10 to the power of 3. Look at your exponents. Who figured out the rule here? We have a 5 and a 3, and the answer is 2. Here we have an 8 and a 5, and the answer is 3. What did we do with the exponents? Subtract. Excellent. Okay, so we can conclude that when we're dividing powers with the same base, we have to write the base, and then all we have to do is subtract the exponents. So as an example, what's 9 to the power of 8 divided by 9 to the power of 3? So we need to write the base. What's the base? Nicole? What's the base? 9. Then what do we have to do with the exponents? Pardon? What's the answer? What do we have to do with the exponents? Subtract. What's 8? Take away 3. 5. So the final answer is 9 to the power of 5. If the base is negative, so if we have negative 9 to the power of 7 divided by negative 9 to the power of 4, will you still follow the rule? You write the base. What's the base? Negative 9. It's the whole thing. So we're going to write negative 9. We write the base. Then we have to subtract the exponents. So what's 7? Take away 4. 3. That's the answer. Good. So we're going to go through these examples. A, 7 to the power of 8 divided by 7 to the power of 4 is 7 to the power of 4. B, Maria.
10 to the power of 5.
Good. 10 to the power of 5. D, Marie. Negative 7 to the power of 7. Good. And the last one, who figured this one out? Jamie. Negative 4.5 to the power of 3. Good. This still represents division. Excellent. Okay, in this last example, we have 10 to the power of 5 divided by 10. What do you think the answer is going to be? If there's no exponent shown, we can imagine that there's the number 1 there. Anything to the power of 1 is still that number itself. 10 to the power of 1, how many times do I write the base? Once. So 10 to the power of 1 is the exact same thing as just writing the number 10, right? So whenever you don't see exponent, you want to imagine that it's to the power of 1. It represents the same thing. So 10 to the power of 5 divided by 10 to the power of 1 is 10 to the power of 4, okay? We have to put a 1 there. It's not nothing. It's not a 0, because that will change the whole value.
Made with Doodlecast Pro.